To properly diagnose steering complaints, it is important to understand the complete steering system. Many factors outside of the steering system will affect steering performance. Suspension misalignment, looseness or binding in front-end components, mismatched tires, a dry fifth wheel, and more. Often, a steering gear is replaced needlessly because an orderly diagnostic procedure is not followed. Begin your diagnosis using the following outline as a guide. Step 1. Define the complaint. Talk to the driver. Obtain a clear understanding of what the complaint is. If possible, try to duplicate the condition by driving the vehicle together and asking the driver questions. Continue to ask questions to determine if the problem occurs under certain conditions. Try to determine if any steering system components have been replaced. Finally, ask questions pertaining to regular maintenance, including whether the steering system had the air bled from it, and if so, what procedure was used. This is especially important on a dual steering gear equipped vehicle for which the procedure is very specific. Step 2. Visually inspect the vehicle. Check the fluid for proper level. Does it smell burnt? The system could be overheating for any number of reasons. Is the fluid foaming with lots of air bubbles in it? If so, check for leaks on the suction side of the pump, hose fitting O-rings, loose hose clamps, etc. Check for a dry fifth wheel. The drag from lack of lubrication will tend to steer the vehicle. Check tires for mismatch, improper inflation, and even wear patterns. Check for uneven loading of the vehicle. Added equipment, such as booms, winches, snowplows, and spreaders, or special body configurations, should be checked for their effect on steering angles and effort. Check if the suspension was modified with the addition of an axle. This may require a different pitman arm or drag link than the vehicle was originally built with. Check the suspension. Inspect for worn spring shackles, patterns of excessive wear, out-of-alignment rear axles, which will tend to steer the front of the vehicle. Look for components shifting as the axle is steered, including the steering gear. See if the tires are making contact with any other parts, such as the pitman arm or drag link. Inspect the axle stops. Ensure they are in place and not bent. Inspect the steering column. Ensure the column is not hitting anything as it rotates, and the universal on the input shaft does not hit the bearing cap cover bolts. Look for the steering wheel rubbing against the column cover, and the column rubbing as it passes through the cab floor. Inspect the hoses. Ensure the hoses are in good condition and properly routed. Improperly installed hose fitting can cause a flapper or loose piece of rubber inside the hose. This condition can cause high system back pressure or starve the pump from fluid. Step 3. Inspect the mechanical components. Inspect the steering column. Remove the universal joint from the input shaft of the steering gear and inspect the sliding intermediate shaft for signs of polishing, galling, or binding. Ensure it is properly lubricated. Inspect each universal joint for sticking and proper lubrication. Ensure the universal joints are properly phased. Improper phasing will cause lumpy steering or a hard, easy feel to the steering. Check the pitman arm. Ensure the arm does not contact any other parts. Check for steering gear centering. Ensure the piston is centered in the gear if full steering to one side cannot be reached. Disconnect the drag link and turn the steering wheel to full left, then turn it full right. Count the number of steering wheel revolutions it takes. Divide the number by 2 and steer back to center that number of turns. This centers the piston in the cylinder of the steering gear. The timing mark on the end of the sector shaft should be pointing to the center of the steering gear. The pitman arm timing mark should line up with the timing mark on the sector shaft when the pitman arm is hanging straight down or very close to it. Check the steer axle for binding. raise the steer tires off the ground and steer the axle through its full turn radius. Check it with the engine running and with the engine off. Feel for any binding or hard spots and ensure the axle stops contact the axle in both directions. Set the vehicle on a set of turn plates. Disconnect the drag link from the pitman arm. Grab the tire and turn it until the axle stop hits the axle, then let go. The tires should attempt to return to the straight-ahead position. If they do not, look for binding linkage connections or king pins. Reconnect all links prior to hydraulic testing. Step 4. Test the hydraulic power assist system. Refer to System Pressure and Flow Check portion of this video or the Shepherd Power Steering Service Manual. All tests must be performed with the weight of the vehicle on the ground. Do not apply the service brakes while steering. The parking brake should be set and the rear wheel chocked. The vehicle should be sitting on a solid level surface, clean and dry, preferably a brushed concrete floor. The testing is to duplicate driving conditions as much as possible. Keep in mind, flow determines how fast you can steer, and pressure determines whether you have enough power to steer. With inadequate flow from the pump, you should be able to turn the steering slowly, but it will bind if you try to turn it fast. Too much flow, and the steering could be too easy, or the vehicle could be difficult to control, such as darting and wandering. With inadequate pressure, the steering will be hard to turn. The steering pressure is capable of equaling the maximum pump pressure. Too much pressure can cause the steering gear housing to crack or break, the relief balls to get jammed into the relief spring inside the steering gear piston, hoses to rupture, and other steering components to bend or break. It is critical to have the correct pump flow and pressure for which the vehicle was designed. Heat is the enemy of any steering system. The higher the system temperature, the less efficient the system will operate. Excessive heat causes steering gear seals to begin to deteriorate because they become rigid and cannot maintain their seal. Pump internal leakage increases as temperatures increase, which adds even more heat to the system. Hoses become hard and brittle as heat increases, causing the inner hose lining to break apart, which can get stuck in the steering gear, causing it to reduce steering performance. Normal operating temperature range is between 160 degrees and 210 degrees Fahrenheit. System temperatures should never be allowed to exceed 250 degrees Fahrenheit. To properly test the steering system, use a 0 to 3000 psi pressure gauge, 1 to 10 GPM flow meter, and shutoff valve installed between the pump and steering gear. A thermometer placed directly into the power steering reservoir is also needed and must be capable of reading up to 250 degrees Fahrenheit. The Shepherd Pressure and Flow Test Kit number 5517641 is available directly from Shepherd by calling 1-800-274-7437.